Hello, everyone. This is Yonggan from the Efficient and Intelligent Computing Lab at Rice University. Today, I will present our work, Patch 4, which tries to answer the question, are Witten transformers always robust against adversarial perturbations? Recently, we have witnessed the success achieved by Witten transformers in various computer vision tasks, including image classification, object detection, and image processing like denoising, derailing, and resolution. However, DNNs are known to be vulnerable to adversarial attacks. That is, an imperceptible perturbation in the model input can totally mislead the prediction of DNN models. Therefore, a natural question is, are VITs robust learners against adversarial attacks? To understand this, we conduct extensive experiments to compare the robustness of VITs and CNNs across different adversarial attacks, including PGD, auto attack, and CW attacks, and find that VITs are consistently more robust than CNNs with comparable model complexities under all existing adversarial attacks. This observation is consistent with previous works. However, considering all existing attack schemes are designed for CNNs, we wonder, are VITs always more robust learners over CNNs? In this work, our answer is no, and we find that the vulnerability of VITs hasn't been exploited by existing attacks. In particular, we propose a new adversarial attack framework, Patch 4, to attack the basic component patch in VIT's self-attention calculation, which for the first time shows the vulnerability of VITs over CNNs based on extensive experiments. We also discovered that the perturbation density and strength are two key determinators for the robustness ranking between VITs and CNNs. Here's a proposed Patch 4 framework, which attacks the basic component patch participating in the self-attention calculation. As shown in this figure here, perturbing only one patch leads to significant accuracy drop on ImageNet on top of the DIT-based model. In particular, we formulate our Patch 4 framework as maximizing the task loss by optimizing two variables, that is, the choice of the perturbed patch P and the adversarial perturbation E. We select the perturbed patch with the highest importance based on the column sum of attention map, which describes to what degree other patches pay attention to the current patch. And we also add an additional attention-aware loss to optimize the perturbation E to maximize the attention to the perturbed patch from other patches. We also adopt a gradient surgery to balance the multiple losses, and more details can be found in our paper. We benchmark the robustness of DIT and resonant families on ImageNet as shown in this figure, where we vary the number of perturbed patches and record the robust accuracy. We find that DITs are consistently less robust against Patch 4 than ResNets under a comparable complexity. We also propose two variants of Patch 4 to understand what factors impact the robustness rankings between VITs and CNNs. The first is Sparse Patch 4, with only a few pixels perturbed per patch, which is achieved by learning a binary mask on top of the perturbations. And the second is Mild Patch 4, with a constraint on the perturbation strength of each pixel to reduce the attack visibility. We evaluate the robust accuracy of VITs and CNNs against Sparse Patch 4 with varied global perturbation ratio of the whole image, and find that under a low perturbation density, which is defined as the number of perturbed pixels per patch, DITs are more robust than ResNets, while under a high perturbation density, ResNets become the winner of robustness. Similar observations can be identified with our Mild Patch 4. That is, under small perturbation strength, DITs are more robust than ResNets, while under large perturbation strength, ResNets become the winner of robustness. These results indicate that the perturbation density and perturbation strength are the two key determinators for the robustness ranking between VITs and CNNs. And the key insight here is a higher perturbation density or perturbation strength will make VITs the loser in robustness. That's all for the presentation, and please refer to our paper or our post session for more details. Thanks.